My talk is mean and extreme climate change impact on state water project. This is part of California fourth California change assessment. This is one of the major application of the CWEMF we released. This is a teamwork. Eric Hongbin, Tara Smith, Francis Chang also involved in this work. And how to evaluate the climate change impact on state water project. This is the approach. Major feature. One of major feature is we're using 20 CWEMF projection. CWEMF means climate model comparison project. Fifth phase. Okay. Now is sixth phase. This is model projection for IPCC report AR 5. Yeah. So, and then also because we also need to downscale this climate model projection because it's so cost. So we're using local downscaling method to downscale climate model projection. Local means localize construct analog divided by script institution script oceanography. Institution of oceanography, yeah. And after downscale, we put downscale precipitation temperature into the Vickers surface hydrological model to generate the inflow. This inflow also calibrated, also bias corrected by scripted institution of oceanography, and also using the variable perturbation ratio to perturb historical inflow, perturb historical temperature, perturb precipitation data to generate flow and also generate demand. We also using the sea level rise, variable sea level rise for each climate model projection. We also calculate the water demand under the climate change. The major part of this feature is we're using CWEMF to evaluate climate change impact on state water project. And why we still using the perturbation ratio? Somebody asked me why, or why not put GCM generated precipitation temperature or inflow data into CWEMF model? Because right now we have issue with the inter-annual variability simulated by GCM model. We cannot use that inter-annual variability simulated by GCM. Like you can see, this is I did some spectral wavelet analysis for 23 for natural flow in California, entire California. And this vertical is relative spectral power relative to 95% confidence level wave power. Okay. So if larger than this horizontal is the return period. So if larger than 1, that means this oscillation or wave is significant. If under 1 is not significant. You can see in California, basically California water precipitation or stream flow inter-annual variability affected by ANSO, QDO quasi-decadal oscillation. This is the PDO Pacific decadal oscillation. This is 3 oscillation in atmosphere. In atmosphere, and you can see ANSO is people familiar with. This is around the 5-year return period, and the QDO. QDO is people just ignore that right now. It's because, but you can see it's more significant than ANSO. The effect California, right? Okay, so they affect California climate a lot. You see, because this is more significant than ANSO and PDO, but this is around the 14-year period. it's okay. So the fact that California the climate change, climate internal variability. So around the 14-year period, term period. Look at the this is the 20 GCM or 10 GCM. What's going? 10 GCM simulated historical climate. So you at the same wavelength analysis, you can see this two climate model didn't generate this ANSO, QDO, PDO well. So this is internal variability very important to our water supply analysis because like long-term drought, 5-year, 6-year long-term drought came from QDO. So if we ignore QDO, then or GCM cannot generate QDO signal. You put this GCM projection into the calcium model, water parameter, you have an issue, right? You cannot simulate this long-term drought effect on water supply well. This is my point. Okay, so we select the 20 climate model projection from 10 climate model and 2 emission scenario. You can see this is ensemble mean. The northern California is wet, southern California is drought. Temperature, you can see we have in middle of central. In middle of central, we have 2 degree and 2.5 degree warming, and also because northern California is wet in the middle of central projected by GCM, so you can see that rim inflow also increased by increased. Yeah, this is wait. Oh. No. Sorry. Okay. So the what? I just.
Can you run ID for him?
Bigger.
Okay. Yeah. Oh, okay. Okay. So rim inflow increased by 44%. You can yes. I just.
Just use the point. Don't touch this too.
Oh yeah, I know. It's anyway. Just when you release is gone. Okay. So I just so you can see the left the panel is annual inflow to Sacramento River Basin rim inflow. You can see the purple line is base. I mean without climate change. The blue line is climate change. In the middle of century, climate change inflow, and then dashed line is 95 confidence level. So you can see the inflows increase, especially high flow period. And the right panel is monthly, long-term mean monthly rim inflow. So you can see the blue line is climate change inflow in the middle of century. Purple line is base. The peak inflow is shifted 1 month earlier. So due to the early snow melting and the quick snow melting, and also high ratio in the rain or in the precipitation. So, and this is a variable sea level rise. We using the different sea level rise for the different climate model projection because we just have half feet, 1 foot and 1.5 foot sea level rise and ANA to simulate the relation between the delta salinity and also outflow. So we have to assign this 3 sea level rise to each climate model projection. So average is well, just wait a minute. The average for the 20 climate model projection sea level rise is 1 foot sea level rise in the middle of century, consistent with the fourth settlement committee. They suggest. And next, and we also calculate water demand under the climate change. In the middle of century, we just perturbed the evapotranspiration, potential evapotranspiration rate, and using the temperature in the future. And we found that in the Sacramento Valley, the demand increased 6.5% because of the evapotranspiration increase. And the other effect I didn't consider in this research. And next, and this is the result. After we perturb the remaining flow, perturb the evapotranspiration rate, and then demand, we put this input data into the CSM3 model and run CSM model for each climate model projection. So then we got this result. Basically, you see, this is go back to you. And purple line is climate change, purple line base, and blue line is climate model projection in the middle of the century. You can see the overall is decreased for all of range data input. So an example mean of the 20 climate model projection, you can see the data data export is decreased by 10%, which is 521 TAF, range from the negative 44% means the reduction to 21% means increase because we have 20 climate model projection, and 16 GCM projection project export reduction. 9 GCM projection, they project a precipitation increase, but only 4 GCM project export increase. And next, and the carryover storage, data carryover storage, you can see same. The purple line is base, and the blue line is climate model projection in the middle of century. You can see the north of data carryover storage on the average, example average decreased by 24% in the middle of century, and in a drought period, because this is drought period, and decreased by half during the drought period, and change a little in the flood episode. So this data carryover storage in the reduction, the change range from 62% reduction to 7% increase, something like that. Next. So this is the data inflow in the middle of century. The blue line is base. The purple line is climate change. You can see this is the upper panel. You see, in the winter season, outflow increased a lot, right? And summer season, data outflow is decreasing. This is if you why cause that? You can see if you look at the monthly river inflow to Sacramento River Basin, you can see in the middle in the winter time, because of the seasonal pattern shift and also annual inflow increase because of this wetting trend projected 20 climate model projection, you can see river inflow in the winter is increased. This increased flow in the winter, they mostly go to the delta outflow. So not next. So how many minutes left?
14 minutes, 16 minutes.
Okay. So this is the extreme climate model, extreme climate change impact on the state water project. How to do that? We select the driest climate model projection among 20 climate model projection. So this is the driest climate model projection is from SS 1.0, and under the emission scenario RCP 8.5. So this is from this Australian climate model, and so this is you can see precipitation change overall. California is very dry, like Southern California, and it's 30% here decreasing in the middle of the century, and the temperature change it's basically it's 3-degree warming in the middle of the century. Next. So how this driest climate model projection this project this climate change impact on State Water Project and Central Valley Project. You can see this bar graph. I select this driest period in the historical, two driest period in the historical. So, and yellow bar is the driest year in 5 or 6 year period, and it's that you can see it's green bar is middle of century for whole 5 years period average, and the blue bar is not a base. The base is not the right word. It's overall average for that climate model projection impact. Overall, no matter it's wet year, it's above normal year, drought year. This is base that. So you can see for the driest climate model projection due to future severe drought period, that export will reduce half of export in historical severe drought period. For the future driest year, 1 year, that export will reduce to 1420 TF, only about 1/4 of normal of the export. Normal export is 5,000 TF. Okay, next. So this is funding. You can see in middle of century, source of delta export were 20% reduction, carry over story were 24% decreasing, and also despite a significant increase in winter rain inflow to secondary river basin in 2060, projected by 20 climate model projection, okay, selected by CC Tech. Most of this increase in rain flow do not become data export or carry over story, but became a net data outflow to Pacific Ocean, okay. And for the driest projection, data export were reduced by 44%, and in 2060. And I conclude my section. Yeah, if we have a question. Yeah.